So in this tutorial, we are going to talk about complex numbers. So we solve a lot of questions under complex numbers. So I have the question here, the first question, which is saying, perform the indicated operations, simplify and write the results in the form of x plus iy. Okay, so any expression which you are going to have, which is in the form of x plus iy, sometimes it can be yi, is what we call a complex number. So a complex number has got two parts. Okay, the part which doesn't have I is what we call the real part. The part which has got an I is what we call the imaginary part. Okay, so if I've got sometimes they can use a and b, they can say a plus bi, sometimes it can be ib, that is okay. So you can clearly see that a doesn't have I, that is the real part. B has got I, that is an imaginary part. Okay, so that is complex numbers. So complex numbers, one thing you have to understand is that when we're talking about complex numbers, it's a number which has got both real part and imaginary part. For example, I can give you the square root of maybe -4. Initially we know that this is undefined, but if we go to complex numbers, then we'll say this is 2i. What does it mean? We're just imagining. It doesn't exist, but we're just imagining to say it is 2i. Now that I chose us to say it is a complex number, we are just imagining, okay, it's 2i. But we'll talk more about this I. Okay, so before we solve this, I want us to talk more about I. So if you have got the square root of 1, initially this is I, so I shows us that this is just imaginary. Okay, so if I can square both sides, I can clearly see that I'll have I squared to be equal to what? To be equal to 1. -1 in this case, because inside we have got -1. So I'll end there. Where there is I squared, we have to replace it with -1. But we'll talk more about I later. Okay, now let's start. So the first question is addition. We have to add this and that. The best thing to do is just to open the brackets, but if you can solve this, you can just pause the video and work it out, then continue to see what we're going to do. So we have 3. Okay, we have 3 minus 4i, then plus -5 plus 7i. I can just open the brackets, or I can do times. This is positive times what is inside there, so I'll have 3 plus 4i minus 5 plus 7i. So we add the real part and the real part, the imaginary and the imaginary. So in this case, 3 minus 5 is -2. Then -4 plus 7 is 3i. So we are trying to write this in a form of x plus iy. So in this case, x is -2, iy is 3i. As simple as that. So that's the answer for the first part. Let's go to the second part, which is 4 plus 2i in the brackets minus -1 -3yi. First, I will rewrite this. I will just open the brackets. So I'll say negative times -1, here is going to be +1. Even here is going to be plus 3i. Because of this negative in between, at this point I can now say the real part and then the imaginary and the imaginary. So the real part is 4. 4 plus 1 is what? Is 5. okay, plus 2 plus that one is 5i. So that is my answer. We go to the next one. We'll see that is 2i. Now this is multiplication now. 3 then 2 divided by 5, like that. Now there is I here. So you do one by one, this times that, again that times that. If you don't want to make any mistake, I would advise you to use this, because this is the same as 2 open brackets 3 minus 2 over 5i, like that. Then again you say plus I, then open brackets 3 minus 2 over 5i, like that. So have 2 times 2 is 6. 2 times that one will get 4. 2 times 2 is 4, to 4 over 5i, then plus I times 3, 3i. Next I times what I have there is going to be 2 over 5 I squared. 2 over 5 I squared. Now I can simplify this. I know that I have the imaginary part, or what we can do is 6 minus 4 over 5i plus 3i minus 2 over 5 I squared. We said we have to replace where this I squared with neg 1, meaning negative 1 negative, and that negative is going to give us now positive. So we'll end up having 6 minus 4 over 5i plus 3i. Then now this is going to be plus because of this negative and that negative, so it will be 2 over 5, like that. Now the next thing I have to do is 6 and 2 over 5, they have to be added. Negative 4 over 5i plus 3i have to be added as well. So I'll start with 6 plus 2 over 5. Okay, so the common denominator is 5. 1 into 5 is 5. 5 times 3, that is 30. So I'll put 30 here, plus 5 into 5, 1. 1 times 2 is 2. So I'll have 32 over 5, like that. So now I have 32 over 5. I need also to add the imaginary part, which is negative 4 plus divided by 5 I plus 3i. Here I'll put 1. The common denominator is 5. So 5 into 5 is 1. 1 times negative 4, negative 4. Plus now this is I. Because of that I, we should have 1 into 5 is 5. 5 times 3 I is going to give us what? It's going to give us 15 I. So negative 4i plus 15, that will be 11. So 11i over 5, that's what I'm going to have here, plus 11i over 5. So the best way to rewrite this is 32 divided by 5 plus 11 over 5, then you put I here. So this is my answer. Or in case you have not seen the answer, that's the answer. 32 over 5 plus 11 over 5i. Now we go to the next one, which is open brackets. We have 3 over 4 plus 5i, again open brackets, and then so this is addition, this is subtraction, and these two, they are multiplication. So I'll have 3 over 4, again, yes, 3 over 4 minus 5i again. So we do times. Now, so here what we're going to have is, I'm going to have 3 over 4 open brackets 3 over 4 minus 5i, then plus 5i open brackets 3 over 4 minus 5i, like that. Then 3 over 4 times 3 over 4, this is going to give us 3 over 4 times 3 over 4, this is going to give us um, it's going to give us 9 over 16. So I have 9 over 16, okay, then minus 3 times 5 is 15 over 4i, plus 5 times 3 is going to be 15 over 4i. Then 5 times negative 5 is negative 25. Now there's 25i squared, like that. Now we can clearly see that these two things can be cancelled out. It's going to give us 0. Then I'll end up having 9 over 16 minus 25. I squared is neg 1, so I've replaced that one with neg 1. So I'll have 9 over 16 plus, now because of negative 1 and negative 25. Here there's 1, so I'll say the common denominator is 16. 16 into 16, 1 times 9 is 9. 1 into 16 is 16, then 16 times 25. Okay? 16 times 25 is 400. So 9 times 400, or 9 plus 400, sorry, which is 409, divided by 16. Because of this 9, there is no number which can go into 16 and 409, so I'll end there. Now what you should know is that if you have got a number just 2, we still have the real part and the imaginary part. So in this case it's the same as 0i. So this is the real part and this is the imaginary part. So like in this case they are saying we should write our answer in x plus iy. So what does it mean? Our x is this which we have, which doesn't have I. The one which has got I, in this case this can be written as 409 times divided by 16 plus 0i. So 0i is the imaginary part, 409 over 16 is the real part. Okay, because we are supposed to write this in form of x plus iy, so it's supposed to be 409 over 16 plus 0i, as simple as that. Now the best thing, again, you can also use another method to solve like this question, because one thing we have to understand here is that we have the conjugate of each other. In a case where you don't understand the conjugate, I'll explain. If I have 2 plus 4i, the conjugate of this is 2 minus 4i. The one having I, you need to, if you have got negative, you're going to put positive. If you've got positive, you put minus. Okay, now one thing we have to understand here is this is the conjugate of each other, this is the conjugate of that, again that is the conjugate of that. So I'm going to get to say this was the original one, then the conjugate is that. But at the same time you can think of this, then the conjugate of itself is that one. Now you just square the one having negative. Okay, in this case I'll check, this is the part 1, part 2, which one has got negative? Okay, it's the second part, so I'm going to square that part. What do I mean? 3 over 4, if I square it, minus 5i, then I square it, I'll end up having the same answer. So if you're multiplying the number by its conjugate, if you just square the one having negative, that is the answer. So in this case I'll say 3 times 3 is 9, 4 times 4 is 16, minus 5 is going to be 25i squared. I squared is going to be replaced with what? It's going to be replaced with neg 1. Again, I'll end up having this 25, which is the same as 409 divided by what? Divided by 16. You see, so it's the same thing. Now we move to the second part. So now the two questions we're from doing, this one and that one, they are from multiplication. This is addition, this is subtraction. The next one is division. Now division, for you to work out that one, we use what we call the conjugate. So let me introduce the concept of conjugate. Okay, How do you work out with the conjugate? If there is division, we multiply by its conjugate, okay, to remove the I on the denominator. That's the whole purpose. So if you have got 2 plus 3i, the conjugate of this is 2 minus 3i. What if you have, I give you a different one, 2i minus 3? The conjugate of this can be written as, because we know that complex number is in the form of x plus iy. So this can be related to say negative 3 plus 2i, like that. And then the best thing you need to do here is you can say negative 3 minus 2i, that is the conjugate. So you change the sign where the part which has got what, which has I. Okay, so let's go ahead now and solve this one, the division which we have here. So 1 plus 3i divided by 3 plus I. So I'll say this times the conjugate of the denominator, so it will be 3 minus I divided by 3 minus I, like that. Then I'll start now. 1 times 3, which is going to give us what? 1 times 3 is going to give me 3. Then 1 times negative I is negative I. Then 3 times 3, 3i times 3 is going to give me 9i. Then 3i times negative I is negative 3i squared. Then divide it by, so this one you can say this times that, but again, for this one, what I'm going to do to make things simple and easy for us, I'm going to square the one having negative. What does it mean? It's the same thing, saying this times that, again that times that. It's the same thing. So, but you just square the one having negative. I square this, I put them in brackets, minus I also put it in brackets. You square it. So I'll end up having 3 I, and that one I'll have plus 8i, then minus 3, then I squared will replace with negative 1. We divide this by, this will be 9 minus this will be negative 1 because of I squared. So I'll end up having, this is going to be 3, because of this negative, this is going to be plus 3, then plus 8i divided by what? Divided by 9 and negative, this is going to be plus, so it's going to be 10. Now we can clearly see that this is going to give us 3 plus 3 is 9. 3 plus 3 is 6. So I have 6 plus 8i divided by 10. But remember, we are trying to write this in form of x plus iy. So I'll say this is the same as 6 over 10 plus 8 over 10i, like that. Then I'll start now dividing. 2 into 6 is 3. 2 into 10 is 5. Plus 2 into 4, because I know that 2 is the one which can go into 4 or into 8 and 10. So I'll say 2 into 8 is 4. 2 into 10 is 5. Then I put I. So this is my final answer for part 5. Now I go to the next part, but the next part, I believe you can do the same thing we are from doing and come up with the answer. So what you can do is you can solve this and send me the answer in the description. If you have my number, you can send direct to my inbox. Okay, so for those who are not registered, if you want to be registered with Transcended Institute, you can just get in touch with us or follow the link in the description, and then you'll be able to be part of the team. Okay, so I'll not solve part 6 because it's the same procedure. Just follow the same thing and solve it. Okay, and then send the answer in the description or in the comment section. If you have got a chance, you can just type the answer in the comment section and then I'll check it out. So let me go direct to this one, which is 3 minus I then I've got 2 plus 3i divided by 1 plus I, like that. So the best thing is to simplify the top part. The top part I know that is multiplication. Okay, so let me just work out with the top part there, which is 2. It's the same as 2 open brackets 2 plus 3i, then minus I open brackets 2 plus 3i, like that. 2 times 2 is 4, 2 times 3 is 6, but there is I, minus or first I'll say negative I times 2, it will be negative 2i. Negative I times that one, it will be 3i squared. So this will be 4. These two can be added, which is going to give us 4 plus 4i minus 3, then there's negative 1. So this and that is going to be plus because of this negative, so it will be 4 plus 3, which is 7. 7 plus 4i. So I'll replace now the top part with what I'll say is 7 plus 4i divided by 1 plus I, like that. Okay, let me do it. Maybe I've made a mistake. I'm saying 2 times 2 is 4, 2 times 6 is 6i, then negative I times 2 is negative 2i, negative I times 3i, negative 3i squared. So these two, 6 minus 2 is 4, which I have there, the 4 here, and then there is going to be 7. Yes, it's just okay. Now at this point I can conjugate. What I'm going to do is I'll say I minus 1 minus I divided by what? Here now is going to be, this is going to be again 1 minus I. So I'll start 7 times 1 is 7. 7 times negative I is negative 7i. 4 times I is plus 4i. Then 4i times negative I is negative 4i squared. The down part, if you want, you can do 1 by 1, or you can just square the one having negative, which in this case is this one. So 1 squared, put them in the brackets, minus, don't square the negative, like that. So it will be I'll have 7, then these two can be added. Negative 7i plus 4 is negative 3i. This is going to be negative 4 times this negative, which is going to give us plus. The down part is going to be 1 minus, because of that negative is going to be like this, negative 1, because I squared is negative 1. So we'll go there and say this is going to be 7 plus 4, because of this negative here and that negative will plus, minus 3i. Divide this by, down part will have plus, so it will be 1 plus 1 is 2. The next thing what I'm going to have is 7 plus 4, which is 11, minus 3i. You divide this by 2. I can write this as same as 11 divided by 2 minus 3 over 2i. So this is going to be my final answer in this case. Okay, so you can use the same procedure which we're just from doing to answer part 8. Okay, so part 8 is going to be 1 plus I, and then I also have 1 minus 2i. I divide this by 2 plus I. Okay, then 4 minus 2i. So now what I'm going to do here is I'm going to simplify the top part and the bottom part as well, and then we conjugate it. So I'm going to say 1 times 1 is 1, then 1 times 2i is 2i, then next I'll go to I. So I times 1, I'm going to get plus I, then I times negative 2i is 2i squared, so it's negative 2i squared. So remember, where there is I squared, we replace it with neg 1. So I'll go to the bottom part now. I'll say 2 times 4 is going to be 8, then 2 times negative 3i is going to be 6i, then I times 4 is going to be plus 4i, then I times negative 3i is going to be, now bottom part here I've got 2. Oh no, we are solving this one, so it's I times negative 3i, which is the same as what? Negative 3i squared. Okay, so now I'm going to simplify further to say 1, then the negative 2i plus I is negative I. Okay, then negative 2, here there is I squared, so I'll put it negative 1, then I'll divide it by 8. I've got 8, and then I'll have negative 6i plus 4, which is negative 2i. And then I'm going to say I squared, I'm going to replace that part with negative I, like that. Okay, so the next thing what I'm going to do is, I know that this is going to be plus now, so I'll have 1 plus 2, which is going to be 3, minus I. Then the bottom part, I know that it's going to be 8 plus 3, which is going to be 11, minus 2i. So now I can conjugate the denominator. So I'll just create space on top here, and then I'll have 3 minus I, then 11 minus 2i. Then the next thing, I'm going just to get the conjugate of the denominator. So I'll have 11 plus 2i divided by 11 plus 2i. Okay, so the top part I'm going to do one by one, but the bottom part I'm doing times the conjugate, so I'm going to get the one which is having negative, then I square it. So I'm going to say 3 times 11 is 33, then 3 times 2i is plus 6i. Okay, then negative I times 11, negative 11i, negative I times 2i is plus 2, or is negative because of the negative which I has, so it will be negative 2i squared, like that. Then now here, instead of me wasting time doing one by one, I'll square the one having negative. In that case is 11, so I'll say 11 I square it, negative 2i I also square it, so I'll end up having 33, then 6i minus 11, that should be negative what? That is negative negative 5. So I'll have negative 5 I, then this is negative 2, but is squared, I is squared, so I'll put it, I'll replace I squared with negative 1. The bottom part, 11 times 11 is 121. Then here I have got 4 I squared. I squared can be replaced with so I'll have this part is same as plus, so I'll have 33 plus 2, which is 35, then minus 5i. I divide this by the bottom part here is 121 minus 4, then again I'll put I. So from there now I'm going to say 35 minus 5i. I divide this by, so this is going to be now plus, it's going to be 121 plus 4, which is 125. So I'll have 125 here. So we want to write this in form of x plus iy. So x plus iy, then I'm going to isolate this. I'll say it is 35 over 125 minus 5 over 125i. 5 can go into 35. Okay, so 35 divided by 5 is 7. Then 125 divided by 5, that is 25. Okay, minus again here 5 into 5 is 1, 5 into 125 is 25, so I have got I. Now I can clearly see that this part is the real part, then the next one is the imaginary part. In this case 7 over 25 is x, then negative 1 over 25i is iy. Okay, so for the next question you can use the same procedure, although this one is simple. You can also use the same procedure, you work it out, you come up with the same answer. Okay, so we're now on question 9, which is 5 minus 4 in the brackets, which is 4i, minus 3 plus 7i in the brackets, then divided by 4 plus 2i in the brackets, plus 2 minus 3i in the brackets. So how can we work out this one? So this is also direct. It's just a matter of us opening the brackets. So in that case, I'll say 5 minus 4i, then I'll open the brackets, minus 3 minus 7i. Then down part, if I also open the brackets, it's going to be 4 plus 2i plus 3 minus 3i, like that. So this, we are solving this one here, which is 9. Now I've just opened the brackets there. So 5 minus 3 is 2. Then negative 4 minus 7 is negative 11i. I divide this by 4 plus 3 is 7. Then 3 minus 2 is negative 1, which is just negative I. Now we get the conjugate of this. So this is going to be times 7 plus I, even here 7 plus I. So I'll start. 2 times 7 is 14. Then 2 times I is plus 2I. Negative 11 times 7 is negative 77I. Negative 11I times I is negative 11I squared. The down part, just square the one having negative. If you're multiplying this by its conjugate, you square the one having negative. So in this case, I'll square that. Okay, so what are we going to have? On top here, we are going to have 14. Then 2 minus 77, which is negative 75. Then I'll have minus. Now this is I squared, so it's the same as negative 11 times negative 1, which is plus 11. I divide this by 7 squared is 49, minus, here I've got this negative 1. I squared is negative 1. So I'll continue from here. I'll have 14 plus 11, which is 25. Then minus 75i divided by, this is going to be 50. Okay, so to make things simple, I can now divide both sides by a number which goes into 25, 75 and 50. So this is the same as 25 divided by 50 minus 75 divided by 50i, like that. Then I'll say 25 into 25 is 1, 25 into 50 is 2, then 25 into 75, this should be 3. Okay, yeah, this is 3. Then 25 into 50 is 2. So this is my final answer in this case. So we go to part 10, which is 4 plus 5i, everything in the brackets, then plus 2i squared. Divide this by 2 plus I, like that. So one thing we need to know is that I'll just rewrite this the way it is in the brackets. So I'll remove the brackets, plus this is going to be 2. Where there is negative I, replace it. Where there is I squared, replace it with negative 1. I'll divide this by, this one now is the same as 2 times 2 is 4. 4 times 2 times I is 2i. Then I times 2 is 2i. I times I is I squared, like that. So this will be now 4 minus 2. This one will be minus because of that negative 1 there. So it will be 4 minus 2, which is 2, plus 5i. Down part here we'll have 4 plus 4i, then minus what? Minus 1, like that. So we'll come here and say this is 2 plus 5i The down part will be 4 minus that one will be 3. 4 minus 1 is 3 plus 4i. Now I can get the conjugate of the denominator. So it will be 3 minus 4i, 3 minus 4i, like that. So what are we going to have? We'll have 2 times 3 is 6. 2 times negative 4i is negative 8i. Then 5 times 3 is plus 15i. 5 times negative 4i is negative 20i squared. The down part, when you're multiplying this by its conjugate, square the one having negative. So here I'll say 3 squared minus 4i, then I square this like that. It's the same. Even if I do this times that, this time that, it's the same thing. So I'll continue from here. I'll say this is going to be 6 negative 8 plus 15. Okay, what is negative 8 plus 15? That is 7. So meaning is positive 7i. Now there, since we have got 2i squared, it's going to be plus 2 because of the negative I squared is negative. Now I divide this by 3 squared is 9. Okay, then minus, I'll have 4 negative 4 squared is 16. Let's not forget that one. So it will be 16 I squared. I squared is negative 1, like that. So we'll have 6. This is going to give us 8 plus 7i. We divide this by what? We divide this by, it's 9 plus 16. What is 9 plus 16? This is 25. Okay, so my final answer will be 8 divided by 25 plus 7 over 25i. So this is my final answer for part 10. Let's jump to part 11. Although the procedures are the same, so part 11 we have 1 plus I raised to the power 2, 1 minus I raised to the power 3. The best thing here is we expand this, okay, which is going to be 1 times 1 is 1, 1 times I is I times 1 is I times I is I squared, like that. I'll leave this one first, so I'll have 1 plus 2i, then minus 1, because I squared is 1. So 1 and 1 can go. Now I can clearly see that for this part I only have 2i. Let's now expand this. We have 1 times I, again 1 times I, even here 1 minus I, like that. So I'll start with the two ones. 1 times 1 is 1, 1 times I is I, like that. The next thing we're going to have, negative I times 1 is negative I times negative I plus I squared, like that. So let's see what we're going to have. This is going to be 1 minus 2i, this is going to be minus 1. This and this will cancel. I'll remain with negative 2i, like that. So now I have got negative 2i. Let me use a different color here now. I have negative 2i times 1 minus I, like that. So we'll say this negative 2i times 1 is going to be negative 2i, then this will be plus 2i squared. So it will be negative 2i minus 2, like that. Now I need to multiply, so it's like I have 2i open brackets negative 2i minus 2, like this. So I multiply. I'll have this times this is going to be neg 4i squared minus 4i, like this. I can now get rid of this part here. So I'll have negative 4, where there's I squared we put it negative 1 minus 4i, like that. So I can clearly see that my answer will be 4 minus 4i. As simple as that. I'm done with that part. I can now jump to 12, but 12, which is 5 plus 6i, then plus 4 minus I, 3 plus 5i, like that, minus 1 over 2 minus I, like that. Okay. So the first thing here, I'm going to work out with this one, which is in between, because these two are multiplying. So I'll say 5 plus 6i, this one I need to put in the brackets. So this one I'll put it in the big brackets, and then I'll say 4 times 3 is 12, 4 times 5 is 20 I, then negative I times 3 is negative 3i, negative I times 5i is negative 5i squared, like that. This one remains the same. So 5 plus 6i, I keep on bringing this, plus. Now this one we clearly know that this is going to be plus 5 now because of that I squared. So it's going to be 5 it's going to be 12 plus 5. Okay, so 12 plus 5 is 17. So it will be 17, then 20 minus 3. 20 minus 3 is 17 as well. So it will be plus 17i, like that. Then here I've got minus 1 over 2 minus I, like that. Now I can open the brackets for the first part here. So it will be 5 plus 6i plus 17 plus 17i minus 1 over 2 minus I, like that. So the best thing which we can do here is I'm going to say 5 plus 17. So what is 17 plus 5? Which is what? 22. Because 17 plus 3 is 20. Now 2 is going to be 22. So you have 22 plus, and then 6 plus 17. Since 5 plus 17 is 22, so this should be 23 now. 23i, then minus 1 over 2 minus what? 2 minus I, like that. The best thing which we can do here is I can find the common denominator if I want. Here there is 1, here there is 1. So what's the common denominator? In this case, the common denominator is 2 minus I. So 1 into 2 minus I is 2 minus I. So I'll have 22, open brackets, 2 minus I, plus again here 23i, then here 2 minus I. Then here I'll have minus 1, like that. So let's see. We'll have 22 times 2 is 44. 22 times I is 22i. Then plus 23 times that is going to be 46i. Then 23i times I, it will be negative 23i squared minus 1. Everything divided by 2 minus I. I'll continue from this part here. So I can clearly see that this will be negative 22 plus 46. That is 24. So I'll have 44. Okay, 44 plus 26, 24, sorry, 24i. Then now this is negative. Now it is I squared, so it's going to be plus 23. Then minus 1. I divide this by 2 minus I, like that. So I'll have 23 minus 1 is 22. So 44 minus 22 is 22 again. So I'll have 22 plus 24i divided by 2 minus I. Now I conjugate the what? I need to multiply by the conjugate of what? The denominator. So I'll have, let me just do it from here. So it will be 2 plus I divided by 2 plus I. So 22 times 2 is 44. I'll write it here. Okay. Then 22 times I is 22i. Then 24i times 2 is 48i. 24i times I is 24i squared. I divide this by, I'm multiplying by its conjugate square, the one having negative. Okay, so this will be now, we'll now have 44. Now we know that this is going to be minus. In this case, it's going to be minus 24 because of that I squared, so it's going to be 44 minus 24. So what is 44 minus 24? That is 20, because 4 minus 4 is 0, 4 minus 2 is 2, so 20. Then these two we add, 22 plus 48. So what is that? Is 70, because 8 times 8 plus 2 is 10. Then 6 carry 1, so 70. I divide this by, if I square this, will be 4. Then that one will be now negative, negative, it will be this. So I'll have 20 plus 70i divided by 5. This is the same as 20 divided by 5 plus 70 divided by 5i. And this can be simplified to be 5 into 20 is 4. Okay, that is 4. Then 70 divided by 5, that should be 14. So plus 14i. So this is my final answer for part 12. Okay, now let's go to part the last part, which is 2 plus 3i in the brackets. Then again here we have 2 minus I over 1 plus 2i. Now this one we can use, there is one method which we can use, or maybe if you want you can first square each, but the best thing to do here is you work out the one in the brackets first and then later on you square it, which is the same thing. Or if you want, you can rewrite this as 2 minus I divided by 1 minus 2i, then you do this. It's the same thing. So what I'm going to do now is I'm going to work out what is in the brackets first, then I'll come and square it. So I have 2 minus I divided by 1 minus 2i times the conjugate, which is 1 plus 2i, then 1 plus 2i. So I'll have 2 times 2 is 2. 2 times 2i is plus 4i. Negative I times I is negative I. Negative I times 2, it will be minus 2i squared, like that. I divide this by I times 1 times is same as I'll just square the one having negative, like the way we've been doing it. So I'll square 1 squared minus 2i. So you square the one having negative always. So I'll have, I know that this is 2 and this is going to be plus 2, so it's going to give us 4. So I'll have 4 plus 3i, because 4 minus I, 4i minus I is 3. I'll divide this by 1, then it's going to be minus 4 negative 1. So I'll have 5 down there. So I'm going to have 4 plus 3i divided by, this is going to give us what? It's going to give us 5. It's going to be 1 plus 4, which is 5. So I can write this as like this, and then here replace it by 4 plus 3i divided by 5. Then now you square this. It's the same thing. So now this again, it is the same as 2 plus 3i. Okay, then you have 4 plus 3i, I square it, then even this one we have to square it, which is going to be 5 squared is 25. So we can simplify first the top part, and then later on we do it with the one which is here. So I'll say 4 times 4 is 16, then 4 times 3 is 12i. Again, 3i times 3 is 12i. 3 times 3 is 9i squared, which is going to be 9 minus, because this is going to be minus, I squared will give us minus. So it will be 16 minus 9, which is 7. So I have 7 plus 24i. So now I have got 2 plus 3i, then 7 plus 24i divided by 25, like that. So we come here and say, I'll continue from this part here. So we are doing now, we are multiplying. So it is 2 times 7 is going to give us 14. Then 2 times 24 is 48 plus 48i. 3 times 7 is 21i. Then 3 times 24, that should be 72 I squared plus 72 I squared. I divide this by, I have now 25 down here. So I have 14. These two can be added, which is 48 plus 21. So what is 48 plus 21? That is 69. So I have 69. Then 72. Yeah, 72 minus what? 72 squared is going to give me negative this. I divide this by 25. So here there is I. Let's not forget. So I have 14 minus 72, which is giving me negative 58. Okay, plus 69i divided by 25. So you can write the final answer as negative 58 divided by 25 plus 69 over 25i. That is my final answer. So that is it for question 1. Okay, we are now on question 2, which is saying find the real RE. It is the real part, which is the real Z. IM is the imaginary Z, given that Z is equal to what we have, and also the part 2 is Z is equal to what we have there. So I'll start with the question part 1. Now this question you can use you can approach it in 2 ways. But the best way, you can first conjugate each denominator and then later on you multiply them, or you can multiply them direct. That is just okay. But the best way to do this is conjugate, work out the first one, which is 1 over 3i. First work out with this one, so I'll say 3 plus I divide it by 3 plus I. And then on top here, since I have got 1, I'll have just what I have there, which is 3 plus I. And then here I'm multiplying by its conjugate. Square the one having negative. As simple as that. So we'll have 3 plus I. Okay. We'll have 3 plus I divided by 3 squared is 9. Then here I'll have I squared is negative 1. So I'll end up having 10. So now the first part here, I have 3 plus I divided by 10, like that. I need to work out the second part and then I multiply them. So I'll say 1 divided by 2 plus 3i. This will be equal to 2 minus 3i divided by 2 minus 3i. So the top part, since I've got 1, the first one we had I, not 1. We had I, so it is not 1. Let me show you here. This is I. So we have made the mistake here. When writing, instead of me putting an I here, this is supposed to be I on top here and not 1. So if I multiply by its conjugate, which is going to be plus 3 plus I, so it will be I times 3 is 3I. I times I is plus I squared. I divide this by, here I'll multiply, I'll just square the one having negative because I'm multiplying by its conjugate. So it will be 3 minus 1, 3I minus 1, because I squared is 1, then 9 minus negative 9, negative 1. So we'll have initially it's the same as negative 1 plus 3I divided by 10. Okay, so now that part is negative 1 plus 3I divided by 10. Yes. Now we go to the second part, which is 1 over 3 plus 2, or 2 plus 1, 3I. Multiply by its conjugate, 2 minus 3I, 2 minus 3I. So now on top there I'll have the same because I have got 1. There is no need of me wasting time. 1 times this, I'll get the same 2 minus 3I. The down part, just square the one having negative because you are multiplying by its conjugate. So it is 2 squared minus 3I, then I squared. I'll end up having 2 minus 3I divided by 4 minus 9, I squared is negative 1. So I'll have 2 minus 3I divided by, this is going to be plus now, so we'll have 13. It will be 4 plus 9, which is 13. I'll have 13. So now what I have for the second part, so now I'll have this. I'm multiplying negative 1 plus 3I divided by 10 in the brackets. You multiply this by 2 minus 3I divided by 13, like that. So we start one by one. Negative 1 times 2 is negative 2. Negative 1 times 3, negative 3I is positive 3I. Then 3I times 2 is plus 6I. 3I times that is going to be 9I squared. I divide this, 10 times 3 is, or 10 times 13 is 130. Then I know that this part will give me negative 1, which is negative 2. Those 2 will give me 9I. What else? I'll have now negative 9, then negative. So I can just say is plus 9. I divide this by 130. So I'll end up having negative 2, that is going to be 7, then plus 9I divided by 130. So it will be 7 divided by 130 plus 9 over 130I. Is there any number which can go into 7 and 130? I don't think so. Does if I do 130 divided by 17, but I think the one for 9 and 130, I think 3. We try 3. 3 into 130, it leaves a remainder, so I'll leave it there. I'll say my final answer is this, but the question is find the, so the real part z is 7 over 130 and the imaginary z is 9 over 130 I. As simple as that. So that is it for the first part. We go to the second part now. So the second part is z is equal to this. The best thing to do this is I'll first multiply this by that, then I'll come ahead and also multiply it by the third one. So 1 times 1 is going to give me 1. 1 times negative 2i, negative 2i. I times 1 is plus I, then I times negative 2i, negative 2i squared. So I simplify this, is going to be 1 minus negative 2 plus I is just I, minus 2, then I have got negative 1. So these two are going to give me plus, which is going to be 3 plus, or 1 plus 2, which is 3, minus I. Now, down part here, I have this. Like that. So I'm multiplying those two. I'm multiplying those two. So 3 times 1 is going to be 3. 3 times 3i, it will be plus 9i. So this is I. Negative I times I is negative I. Negative I times 1, sorry. Then negative I times 3i is negative 3i squared. Remember, on top here we have 1. So we have 1 divided by 3 is going to be 3 plus 3 because this is going to give us plus of, because of the I squared, so it's going to be 9. Then this is going to be plus 7, 8 I. So I now have 1 over 9 plus 8i. I conjugate this, I'll end up having 9 plus 8i, 9 plus 8i. The top part we have 1, so it will just be the same. Then down part, multiply the one having negative. In this case, I'll multiply this, and I'll end up having 9 plus 8i divided by 9 squared is 81 minus 8 squared is 64. Now I squared is negative 1. So I'll have 9 plus 8i divided by 81 plus negative negative is going to be plus 64. 9 plus 8i. So what is 81 plus 64? That is 145. So the final answer is 9 divided by 145. Then I have plus 8 over 145i. Is there a number which can go into, maybe we try 3. What is 145? 145 divided by 3. It leaves a remainder. What of 9 itself? 145 divided by 9 itself. It leaves a remainder. So this one I'll leave it the way it is. What of 8? I don't think so. So I'll end up there. So I'll say my real part is 9 over 147 or 145. Then my imaginary part is 8 over 145i. As simple as that. So that is it for question 2. Now we're on question 3, which is saying find the values of a and b for which 2a plus 3i is equal to 6 minus ib. Now in this case, this one is very simple, but there is a part where we have complicated equations. I think that should be question 3. I'll explain it. Okay, that should be question 4, sorry, not 3, because this is question 3. So I have 2a plus 3i is equal to 6 minus ib. what we need to understand is that the part which is having a and b, they're supposed to be to the same side. The part which doesn't have a and b should also go to the same side. So I'll shift ib to the other side. I'll have 2a plus ib to be equal to 6. If I shift 3 to the other side, it's going to be minus 3i. What does it mean? This is the real part and this is the imaginary. At the same time, this part we have got, this is the real part, this is the imaginary part. So we equate the real part to each other, the imaginary part also to each other. What does it mean? I'll say 2a should be equal to 6. Then I solve for a. Divided by 2, divided by 2. A will be equal to 3. At the same time, I equate the imaginary part equal to the real part, or the imaginary part. So I've got IB is equal to, now you get the sign. In this case, it's positive. That's why I'm just getting positive here. Is equal to negative 3i. I and I will go. So I'll have B is equal to negative 3. Sometimes when you are getting this, they will tell you to say ignore I. But it's the same thing because I will cancel out. So in this case, A is equal to 3 and B is equal to negative 3. As simple as that. So let's talk about quadratic equations of complex numbers. So this is a very interesting subtopic under complex numbers, and we need to understand it because you are going to be asked several questions in a test or in an exam. So I have the first question. We know that the quadratic equation is in the form of ax squared plus bx plus c is equal to 0. And now in this case we are using z. So z is acting as our x. Okay? In this case. So the best thing to do here is we're not talking about complex numbers like the way this question is, but which is z squared minus 4z plus 5 is equal to 0. This cannot be factorizable. Why? Because it's a complex. We're talking about a quadratic complex numbers, okay, equations. So when you put them in a square root, you discover to say sometimes you end up having maybe negative, and which we know that sometimes we call it undefined, but in this case, since it's a complex number, it's not going to be undefined. Okay, so we use the same formula. We'll say z will be equal to negative b plus or minus the square root of b squared minus 4ac. I divide everything by 2a, like that. So one thing we have to understand is that b in this case is this one, negative 4. Okay, so I'm going to put, since it's negative, meaning it's going to be positive 4, so it will just be 4 plus or minus the square root of negative 4 squared minus 4. The value of a is 1. Here, a number in front of z squared is 1. Then c is 5, like that. And then what are we going to have? We're going to have, we divide this by 2, a is 1. So the next thing, we'll have 4 plus or minus the square root of negative 4 squared is 16. This is going to give me 20. I divide this by 2. So I'll continue this from this side here. I'll say this will be equal to 4 plus or minus the square root of, now I'll have the square root of 16 minus 4 is negative 4 divided by 2. So what is, when I'm talking about complex, if it's a normal quadratic equation, the square root of negative 4, it is undefined. But this is under complex numbers where we have the imaginary, we're just imagining in this case. So the square root of negative 4 is 2i. So I'll say 4 plus or minus 2i divided by 2. So z, since it is squared, we expect to have two answers. So we'll have 4 plus 2i divided by 2, or z can be equal to 4. Now I'll use minus 2i divided by 2, like that. So the final answer in this case is going to be 2 into 2 here. If I want, I can just factor out anyway. I can factor out 2. So I have 2 plus I divided by 2, or z will be equal to, even here, 2 minus I divided by 2. So 2 and 2 can go. So my z will be equal to, so these two can be cancelled out. So I'll have the first z will be 2 plus I divided by, oh, it's just 2 plus I, just like that, divided by 1, but in that case we don't consider 1. Another z will be equal to 2 minus I. So in this case, the value of z is 2 plus I or 2 minus I. As simple as that. That is it for the first part. So that is for quadratic equation, the under complex numbers. Now let's go to part B. So part B, we have 2 z squared plus 2z is equal to -5. Just shift -5 to the other side so that we remain with 0 here. So we have 2z squared plus 2z minus 5, or it's negative now. When I shift it to the left hand side, it's going to be plus 5 to be equal to 0. Then we use the formula, we end up having z to be equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Okay, now let's plug in the values. So what is our b? In this case, our b is, so say this is equal to, our b from our question here, our b is 2. So it will be -2 plus or minus the square root of b is 2. So I'll put 2, I square it, minus 4, a is also 2, then c is 5, like that. I divide this by 4. 2 times 2, which is 4. So we see what we're going to have in the square root. 2 squared is 4. Okay. So I'll have -2 plus or minus the square root of, this is going to give us 4 minus, okay, so 2 times 4, 8, 8 times 5, 40, or you can say 4 times 5, 20, 20 times 2, 40. You divide this by 4. The next thing what we're going to do is we'll have -2 plus or minus, this is going to be the square root of 4 minus this is -36, divided by 4. Okay, so we'll have, I'll continue from here, -2 plus or minus the square root of 36 is 6i, because that is going to give us imaginary, so it's 6i. I divide this by 4, so we'll have z will be equal to -2 plus 6i divided by 2, or z will be equal to -2 minus 6i divided by 4. Let's factor out 2 on top. Z will be equal to -2. Should we factor out 2? Okay, let's factor out 2 and not -2. So 2 open brackets, here will remain with -1 plus here 3i, like that. I divide this by 2, or z will be equal to, again I factor out 2, -1 plus 3i divided by 4, like that. Where is this 2 coming from? It's 4. So I'll say 2, this is 4, 2 into 2, 1, 2 there, 2, 2 into 2, 1, here 2. So I'll end up having z to be equal to -1 plus 3i divided by 2, or z to be equal to -1 minus, so this is minus here, because of that minus here, 3i divided by 2. Now this can be written as the final answer. Now can be written as z is equal to neg 1 over 2 plus 3 over 2i. That is the first answer. Or z will be equal to neg 1 over 2, okay, then minus 3 over 2i, like that. So this is the answer. Also, that is the answer. So that is it for the second part. Now we move to further quadratic equations involving complex numbers. We go to part 3. Part 3, we have I z squared minus z plus I is equal to 0. Same thing, we follow the same. So we have z is equal to negative b plus or minus the square root of b squared minus 4ac, like that. So I divide this by 2a, like that. Z will be equal to negative, what is our b? Our b is negative 1. This is negative z, so it's negative 1 plus or minus the square root of, since that is also negative 1, it's going to be negative 1 squared minus 4. My a is I. In that case, we have been given that a is I there. Then my c is also I. Okay, I divide this by 2. My a is also I. I'll put I down there. The next thing I'm going to do is z will be equal to negative will cancel. I'll have plus or minus the square root of negative 1 squared is 1. Then minus, here I'll have I times I is I squared, so I'll have 4i squared. So I'll have 4i squared. I divide everything by 2i. Okay, I'll continue from here. So 1 plus or minus the square root of 1. This is now going to give us negative, and negative is going to be plus. So I'll end up having 1 plus 4, because I squared is negative 1. So negative 1 times this negative, it will give us plus. I divide this by 2i. So I'll end up having 1 plus or minus the square root of 5 divided by 2i. The square root of 5, unless I use a calculator, but in this case we're not allowed to use a calculator, so I'll leave it the way it is. Meaning I have z to be equal to 1 plus the root of 5 divided by 2i, or z is equal to 1 minus the root of 5 divided by 2i. But we can't leave our answer in this form, because I should not be on the denominator. The answer has to be in a form of x plus I y. So I'll conjugate the what? The denominator. So I'll say 1 plus the root of 5 divided by 2i, meaning times negative 2i, even here times negative 2i. So negative 2i times 1, what are we going to have? Negative 2i times 1, I'll have 2i, like that. Then here I'll have negative 2. Okay, I'll have negative 2. Yes, I'll have negative 2 the square root of 5, then I. Then we divide this by, there you just square the one having negative, meaning it's negative 4i squared. So we end up having negative what? Negative 2i minus 2 root of 5i divided by what? Divided by, this is going to be negative I, or I squared is negative 1. Negative 1 times negative, so I'll have positive 4. So I'll end up having z to be equal to, I can factor out 2 outside. Then I'll have, here I'll remain with I, here I'll remain with the root of 5i. then divide it by 4. So the first answer will be 2 there, 2 there, 2. So we'll have I minus the root of 5I divided by 2. That's my first answer for Z. I also have to work out the second part, which is 1 minus the root of 5 divided by 2I. So I'll do the same, times this. So if I do times, I'll have negative 2I. Again, here is going to be plus 2. You can say 2I times, if we say 2 this, it's the same thing. Even if you write it as this, I root of 5, it's the same thing. But the best way to write complex number is this. I divide this by I square, that one is going to be negative 4I squared, like that. So another answer for Z, we expect it to be negative 2I plus the root of, or we have 2, the root of 5I. I should not be in the square root. Take note on that. And then what we should know here is that this is negative 4, and then we have got negative 1, because I squared is negative 1. So I end up having positive down. I can factor out 2 on top. I will remain with this. I divide it by 4. So I can now cancel out 1, 2. 2 there, 2 there, 2. So another answer will be this. So this is the first part of Z, and another answer is this. So that is it for part 3.